When it comes to dating the age of the Earth, there's only one tool for that. It's radiometric dating. When we want to know about the deep ice cores, radiometric dating. Want to know the age of a moon? Radiometric dating. Age of the meteors? Radiometric dating. You get the picture. Until now, these dates have not favored young Earth creation. As a matter of fact, both heat problems from two of the most popular young Earth creation flood models exist trying to deal with radiometric dates that they give. That said, there are some assumptions that go into radiometric dating. There are 8 major ones that actually go into this, and until recently, none of them could be actually validated. And it's because of this, statements like this abound, and we'll not go over this because of time, but as you can see, there are problems, and they're all based on starting assumptions. So don't forget, I like radiometric dating. I think it's a tool that's one of the best ways that we can actually measure time. So that being said, we are going to focus on problem number 2. And that is when they form, what is it like? So we need to know the Proton 21 laboratories in Ukraine. That's going to be a focal point for this one. Unfortunately, this place exists in one of the worst places in the world as of right now because of a war that's breaking out. But regardless of that, they're working with cold fusion, and they're creating super heavy elements using something called Z-pinch. And this is where it gets really amazing, because one of the scientists that is now working there, before he began working with the formations of iron. Now, what I mean by this is that he was able to create the exact ratio and proportions of iron that we have on Earth today from an experiment. Once this formed, we compared that and we were absolutely shocked. And he got a job working over at the Proton 21 laboratory. So he brought his experience and education into that. And now the elements that have been created at that place, again, match what we see on Earth. But even more interesting is that the daughter elements formed at extremely high amounts of, or a high ratio, higher than we would ever expect. But it's because their decay rate is so fast, they vanish in a few hours or days. So what happened is this got the scientist into thinking, like, how are we going to utilize the high amounts of these daughter elements being produced? Like, what can we do with this? So their goal became that we're going to form high amounts of 3 particular radioactive elements: Titanium 99, iodine 131, and Lutetium 177, which are used for medical cancer imaging research. So that's what the focus is now in that laboratory. So that got me thinking. I'm like, wait a minute, this got my attention, because what about the ratios for other radioactive elements that we use to date the age of the Earth? So this made me jump right over to aluminum-26, which has a short half-life isotope ratio of just 730,000 years. So what's it doing in such high amounts, but not just in the Milky Way galaxy, but even on Earth itself? So the scientists tried to solve this paradox that's going on, and they thought maybe the formation was via cosmic rays from the sun. But the problem is the sun couldn't have made that many cosmic rays for the requirement that's in such a high amount in today's world in such a short amount of time. So they can, I say, throw in any rescue device that they want. But the fact is that when we look at the very formation of these things, even the aluminum-26, we're finding that the observational data matches what we see in the laboratory. So that's what's amazing about this. It solves the paradoxes for evolution. I think that's a great thing as well. But of course, it reduces the age of the Earth to an upper limit of 740,000 years maximum because of that. And then so it made me go over and look at potassium. Lo and behold, potassium ratios are exactly the same that we see on Earth today, in the same proportions that we see on Earth today. This, again, would set the upper limit looking at potassium to just 1.25 billion years by looking at that ratio, let alone 4.56, which is the age of the Earth. That brings us to the next piece of evidence, which would be the lead paradox. Now, this is interesting because we have more radiogenic lead isotopes than there should be, unless, of course, you can see right here on the right side that they said unless the Earth formed 13.9 billion years ago, or 100 million years after the formation of the universe itself. So obviously this is a huge problem, and that can only be resolved through either accelerated nuclear decay or by the observational formation of these elements. Obviously, I'm going to go with that one myself. So I believe this also explains the distribution of the radioactive elements that we see on Earth today that don't make any evolutionary sense, why uranium and thorium are on the crust of the Earth and not deep within the Earth, especially since they're so heavy they would have sunk to the core, or they would have already kind of been in the core because they're powering and creating the power to rotate the Earth itself. But there's also another paradoxes, right? Over 50% of all radioactive materials exist just in Australia alone, as you can see from this map, and 90% of all uranium and thorium is just in Australia. So it's very disproportionate of what would ever be expected. So another analogy would be, I made all of these clocks last week that you can see right here, but they tick at different rates. There's also clocks inside of clocks that also tick at different rates. No one would have ever expected the daughter elements to form as they are today. Not even us young Earth creationists would have actually predicted this. That's probably why this is the first time you're hearing about this. So it comes down to what was expected, which was what the evolutionary community would have expected to find: uranium slowly decaying into thorium and iridium and radon. But what we actually found was more indicative of what the experiment showed, that they actually form at exactly the same time in the proportions and ratios that we see today, the exact opposite of the evolutionary prediction. So at first glance, if you were to actually see these clocks in the ground, you would think, well, they're ticking at a constant rate. So obviously, if we take that assumption and we go backwards in time, we can just reverse these clocks and it would tell us the true accurate history. While true on the surface, the most important question that we needed to ask ourselves before agreeing to that idea is, what happens if we do go backwards and we run out of history? The clocks are still giving it a time frame, but we actually can't judge it off of that. So I could say that I made these clocks last week, and they do tell time perfectly. So I placed these into a computer game from the very start, or the dawn of the program, and all the NPCs using these clocks, and they came up with the same idea that we did. Like, maybe we can reverse these and find out how old something is. But they would need to read the manual to learn that I actually created these just a week ago. And I believe that the Bible is the manual for us that we use to tell us how old something is. And we go with these genealogies back in time, and it's not that old. So the same analogy applies today. I think we can tell accurate time, that they must be able to tell us accurate history. But if you're using them to tell a time about history that doesn't exist, then we have a problem. And that's exactly what happened based upon the most recent concept of evolution. I think they came in with a preconceived notion to begin with, and then they just kind of ran with that by saying, well, if we find this many daughter isotopes, then this much time must have passed. So one final analogy, I guess I could reiterate my position with, which out of all of these clocks tells better time? Well, they actually all tell really good time. But as I said, I only created them last week. So even though they all have the capacity to tell perfect time, even going backwards, we cannot use them to tell us when they formed unless we know some important factors. When these elements formed, what were their parent to daughter isotope ratios? That's the golden question. And today, my goal is to answer that. So then we're going to conclude with, we have the formation of both non-radioactive and radioactive elements being formed in the same proportions and ratios that are on the Earth today. The radioactive elements form with both parent to daughter isotopes in the radioactive, or in the ratios that we find them today. We have the lead paradox, which is solved by either accelerated nuclear decay or the observations made in laboratory experiments, which shows that when lead forms, it exists as it does today, not billions of years ago. It solves the lead paradox. The new discoveries of the rocks in the mantle add further problems for the lead paradox, but it doesn't really matter for us. The new data solves these paradoxes, and but the only caveat to that is it shows that the Earth is young. So if these elements formed just thousands of years ago in the exact ratio that we see them in today in the laboratory, then why assume they represent billions of years of decay? You can't. If they formed in ratios completely different than today, then sure, you have a great case against me and for eons of time passing. But since we now have observational, physical, repeatable, testable evidence on the contrary, Earth can't be old, and the evidence solves these paradoxes that exist in cosmology as well. So it seems to me that you can either accept the observational data that solves the evolutionary paradoxes or reject it, all because it confirms young Earth creation.